So again, trigonometric expressions and functions and those things. I know that you saw some trigonometry last year in geometry, maybe even a little bit in Algebra 1. What we're going to do today is review all the trig that you've seen before. No, let me try this again. We're going to review all the trig that you've seen before that we're going to need for things moving forward. So today should be a review. The rest of this unit, though, will be things you have not seen before. Even though today is review, I would not highly suggest, please do not work ahead with certain things because there are definitely some details that we need to make sure we're getting. This whole unit really is all about like lots of little detail things, and if we start missing those, then all sorts of bad things happen. So stay with me, and things are going to be good. First of all, we have a triangle. Have you seen this Greek letter before in geometry? Yes, this is the Greek letter theta, which is spelled T-H-E-T-A. Theta, not F like the cheese, but theta with a T-H in the beginning. And it's, of course you saw that before. Yes, okay, now that makes a whole lot of sense. I know, yes, that is the name of his dog. So if you had him, you certainly saw that letter before. This Greek letter typically stands for any angle that we're going to deal with. We usually use, x when we're dealing with equations and y when it's the answer to a function, but theta is a particular angle. So I have some angle theta over here, and I have a right triangle. And we can label the sides of our right triangle relative to our angle theta. Well, sort of relative to our angle theta. Before we do that, though, what do we always call the side that's across from the right angle? The hypotenuse. Okay. That is the hypotenuse. As for the other two sides, and Laura, did I get your cumulative review? Did I get your?
Yeah, I did.
Perfect. Okay, just because you weren't here when I collected them. Okay. I'm going to label the side across from the theta as opposite. And I'm going to label the side next to theta, the one that's not the hypotenuse, as the adjacent. Come on in. Thank you. Now, if theta was somewhere else, if theta, for example, was up here, I would not call this side the adjacent. This side would then become the opposite, and that would be the adjacent. So it's always relative to where our angle theta is. There are three trigonometric ratios that we need to deal with: the sine of an angle, the cosine of an angle, the tangent of the angle. These are ratios, these are fractions that tell us how sides are related. The sine of an angle theta, first of all, there's a symbol for the sine of theta, and it is S-I-N. And to show that it's the sine of theta, I'm going to say the sine of theta equals. This is defined as the length of the opposite over the length of the hypotenuse. The sine of theta is the opposite over the hypotenuse. It's a ratio of two sides. The cosine of theta is defined as the ratio of the opposite side. Nope, that's wrong. Sorry. The ratio of the adjacent side over the hypotenuse. Adjacent over hypotenuse. So I've done an opposite with hypotenuse, I've done an adjacent with hypotenuse. What combination haven't I used yet? Opposite and adjacent together. The tangent of theta, tan theta, is defined as the opposite. Yeah, hold on a moment to that, but we're definitely going to get there. The opposite over the adjacent. These give us ratios of sides in a right triangle. This side over that side, this side over that side, things like that. I'd like to take a look at the triangle on the bottom of the page. A little bit, maybe, if we can still see things. We have a right triangle over here, a 3, 4, 5 right triangle. Oh, that's a special right triangle that you dealt with last year. That's a Pythagorean triple. We'll see those throughout this section. I want to find the sine of angle A. Well, the sine is defined. How? Go back to the top. What did we say sine was? Opposite over hypotenuse. What is opposite letter A? 3. What's the hypotenuse here? 5. The sine of A is 3/5. That's it. It's a fraction. It's a ratio. That's all we're looking for. The cosine of A. Well, how did we define cosine? Okay, so Brett, what's the adjacent?
4.
4. And what's the hypotenuse?
5.
5. Your cosine is 4/5. That's it. The tangent of A. Well, how do we define tangent? Opposite over adjacent. Josh, what's the tangent of A? What's the not the tangent yet. What's the opposite from A?
3.
What's the adjacent?
4.
4. That's all we're doing so far. Nod your head if you're with me so far. Okay. Well, I want you to take that same triangle and do the sine, cosine, and tangent, but this time of B. So you're starting at angle B. From there, decide what's opposite, what's adjacent, and those things. Giovanna, what's the sine of B? 4/5. And sure, that looks like the opposite over the hypotenuse. And Shay, what about the cosine of B? 3/5. The adjacent over the hypotenuse, 3/5. And Laura, how about the tangent of B? Good. When you do these, it is really important that there is something inside your sine, cosine, and tangent. We're not just going to say the sine is 3/5. The sine of what angle? It's very different in this picture if we're talking about A versus B, so we need something inside there. Now, we do need to know these 3 trig ratios. Sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And I feel like there was a mnemonic you learned last year. SOHCAHTOA. Or this year, if you're taking geometry this year. I want to write this out on the top of this page. There's actually a kind of different way that I write this, maybe compared to other teachers. Here's how I'm going to write this. The sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. So, sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. TOA, the tangent, is the opposite over the adjacent. Whatever. We just need to know what these 3 things are without constantly looking back at things like that. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Turn the page. So we've got a triangle, and we need to find the sine of C, and the cosine of C, and the tangent of B. So easy enough, the sine of C is the opposite. What's the opposite? Why? Oh, okay. Here's the thing. I don't necessarily have to tell you all 3 sides of a right triangle. I only have to tell you 2. Raising your hand, how do you find a missing side of a right triangle? Lionel. We need to use the Pythagorean theorem. If we are missing a side, we are going to use the Pythagorean theorem to find it. So, yeah, Pythagorean theorem, I guess, is like a squared plus b squared equals c squared, but only if a and b are the legs of your triangle and c is the hypotenuse. I think the better way to deal with this is just one leg squared plus the other leg squared equals the hypotenuse squared. I'm going to say that that leg is x. So I'm going to make a little equation. I'm going to say x squared plus 5 squared equals 36. I'm going to get x squared plus 25 equals 36. Minus 25 minus 25. X squared equals 11. X equals plus or minus the square root of 11. Why not? We always do the plus or minus square root. Here we're talking about a length of a triangle, so no, it's only going to be the positive square root, at least for right now. And that side is root 11. And don't give me a decimal. Give me root 11 there. I'm going to want exact answers for these. And if it was something like root 8, you wouldn't say root 8, though. Why not? We would simplify it. Not an issue here, but other times we would simplify. Lauren, question?
So if we just continue to the 5 range again, and then split the value for knowing that C is always the hypotenuse.
Ask that question again.
So like I did A squared plus B squared equals C squared, but then I put in the 5 for A and I put in the 6.
That's perfectly fine. We're going to see, though, in like another page, we're going to start messing with the letters, and the hypotenuse might be A or B, just given how the triangle is set up. As long as you can get the length, we're fine. Now I feel like you've got everything you need to do the rest of this. So please try the sine of C, the cosine of C, and the tangent, not of C, but the tangent of B. Be careful. And please don't go on the bottom yet or anything like that. Sam Ellison, what's the sine of C? We need to do the opposite, root 11, over the hypotenuse, exactly what Sam said, root 11 over 6. And Brett, what about the cosine of C?
Root 11 over, oh no, I don't know.
So, Brayden, you want to help with the cosine of C?
5 over 6.
I need the adjacent, what's next to C but not the hypotenuse, 5. And what's the hypotenuse? 6. So we're going to go with 5 over 6. And Paige, what about the tangent of B? Oh, wait, hold on a moment. Tangent of B, not tangent of C. I messed with the angle. So, 5 over root 11. Good. Yeah. So, 5 over root, can we get 5 over root 11? Yes, I will mess with changing the letters. It's B here, so I'm dealing with the opposite 5 over the adjacent. Paige, continue what you were saying. We're not allowed to leave square roots in the denominator. We always need to rationalize our denominator, so I'm not going to say 5 over root 11. We're really going to say 5 root 11 over 11. Does that make sense? So again, these are just ratios of sides. I don't want decimals for these things. I need to see a fraction, one side over another side, and then maybe we'll adjust it if we have to rationalize or whatever. Next. Given one trig ratio, find the others. So I'm telling you we have some angle. The sine of that angle is 5/13. I want to know the cosine. I want to know the tangent. Any idea how I could even possibly start to do something, Lauren?
Put in the sig, you hit the sig
Nah,
letter.
nothing on the calculator. Nothing on the calculator. Yasmin. I feel like there's something I should do before I start thinking about those things. Laura? Of what? What type of triangle? There we go. Draw a right triangle. It does not matter if you make this theta or you make this theta, but everything needs to be accurate relative to where we put the theta. I'm going to put my theta over here. Again, doesn't matter as long as we're just consistent. Now I'm ready to do what Yasmin was talking about. So, Yasmin, say that again. Before that, what do we know about the 5, the 13? So, put it over here. Here. The third option, like over there. If I'm telling you the sign of something is 5 over 13, that means the opposite is 5, the hypotenuse is 13, so fill those in.
Is this
Yeah, it is. I would like you to find the missing side either using Pythagorean theorem or using what Michael was about to say that I didn't want him to say just yet. Maybe you just know it. $12? 5, 12, 13 Pythagorean triple. Maybe that sounds vaguely familiar. No, they're going to show up often, though, and if you do know them, you don't have to bother with Pythagorean theorem, because you just know it's a 3, 4, 5 right triangle, or 5, 12, 13, or one of the other ones that we'll come across sooner or later. It might help. What I want you to do is find the other two trig ratios for this thing. So that means I need you to go find the cosine of theta and go find the tangent of theta. Do it.
thing? Wait, what?
So I told you the sine of theta. I now want you to find the other two trig ratios. So in this case,
Sorry.
all
We're
good.
on the other one.
No, not yet. Cosine of theta and tangent of theta. Brittany, what's the cosine of theta?
12 over.
That's it. And Mina, how about the tangent of theta? So I'm looking in letter A over here. Do you have your triangle drawn out? The 5, 12, 13? So I want to know the tangent of theta. 5 over 12. 5 over 12. Good. Opposite over adjacent. So basically, if I tell you one and want you to find the others, well, you draw a triangle and you go from there. I want you to try letter B on your own right now. See what you can do. This one is not one of those Pythagorean triples. You're getting 32 initially for x squared. So you're not really going to say the square root of 32, though. What is it? 4 root 2. Yeah, we can simplify. 4 root 2. Okay, I want the sine of theta. I want the tangent of theta. Sam De Silva, do you have the sine of theta?
4 root 2 over 9.
I want the opposite of hypotenuse, so yeah, that looks good, 4 root 2 over 9. And Molly, how about the tangent?
4 root 2 over 7.
4 root 2, the opposite over the adjacent, over 7. If the root 2 is in the bottom, you'd have to rationalize, but it didn't happen over here. So things are good. Move that up a little bit. Anything so far? I'm assuming this is all review. This is really nothing new yet. Next page. There's some specific notation we have to use when we're dealing with these right triangles. First of all, when we label the sides and angles of a triangle, we label the angles using capital letters. Let me write that over here as a bullet point. Label the angles using capital letters. I'm going to put a capital A there, capital B there, capital C there. Angles are points. You remember from last year that, well, angles are at the points. You remember points are single capital letters, so angle A, angle B, all that stuff. To label the sides. We're going to label the sides using lowercase letters, but we are going to label the side directly across from an angle with the same letter, but lowercase. So here's what I mean, and then I'll write that down. Across from capital A is this side over here. I'm going to label this side with a lowercase a. And I'm going to label this side over here that's across from capital B with a lowercase b, and this side over here with a lowercase c. So we are going to label the sides. Or what are we going to say? We're going to say label the sides, or the side across from an angle, with the same letter, just lowercase. So little a stands for the side across from capital A, little b across from capital B, and all those things. And the next thing we're going to look at, and we're going to use this notation with this, is what we call solving right triangles, finding all the sides, all the angles in a right triangle. You've got a right triangle drawn. I want to go just label some things over here. I want to say that's capital A, capital B, capital C. Take a moment, label your three sides, little a, little b, little c, and then stop. What's this one? Little a. And this one? And this one's little b. By the time we're done, we want to know what all the sides are and all the angles are. And I'm going to just kind of make a list on the side. Capital A equals capital B, capital C. So that's still showing up. Little a, little b, little c. I already know some of this. I know capital C is 90 degrees, and capital A is 57 degrees, and little b is 7. So I only have 3 things to find.
Big C is big B is 33.
What was that?
The big B is 33
Why?
because triangles equal 1.
Yeah. We need to find the missing angle, but that's really easy. All the angles in a triangle add to 180. So 90 plus 57, get an answer. Subtract that from 180, and you should be getting 33 degrees for that missing angle. That's the easy part. As for the rest, We need, well, if we had two sides, we could find the third side, but with only one, we need to use some trig things on the calculator. Please take out your calculator, and we need to first talk about how to set up our calculators to do this. Because there's a specific way we need to be able to deal with this. Your calculator has two different modes to it. Degree mode and radian mode.
Yo.
If you have a graphing calculator, if I turn, no, that's not going to help. If you have a graphing calculator, push the mode button. And the third row talks about radians versus degrees. We don't know anything about radians yet. We will on Tuesday. But we're going to be in degree mode, so make sure degree is selected. If you have a scientific calculator, you should have a button that says either DRG or degrees, radians, or something like that. We need to make sure we're in degree mode. And if you can't find this, call me over and I'll take a look.
Yeah, I don't know. Actually, I got it. You want it in radian mode?
I want it in degree mode. Know about this one. Oh, you're already in degree mode. So we're just gonna leave it and move on with things. Yep, you're gonna have a DRG button. So, and actually right now it says what mode you're in. It says DEG, so you're in degree mode, but if you change it, you can be in radian mode or another one. Anyone else having issues? Okay. Go back to the home screen on your calculator. And just to make sure that we're in the right mode, this is a little test we can use. Type in sine, the sine button, and then type in the number 30. And if you are in the right mode, it's going to tell you 0.5. And if you're not in the right mode, it's going to give you a long decimal. Raise your hand if you cannot get 0.5. Again, the whole point is there are two ways to deal with angles, degrees and radians. Dealing with degrees today and a little bit on Tuesday, but then by the end of Tuesday, we'll talk about those other things. You're getting what?
I had a negative number.
For the sine of 30? Can you go back to mode, go down to that third row and make sure degree was highlighted and you push enter over degree? If this doesn't work, I'll come over and take a look.
Sign of what?
Sine of 30?
0.5.
0.5. Okay, so here's what we're going to do. I want to find my missing sides. I want to find A, I want to find C. Let's find A. And I want to use that 57 degrees. Watch this very carefully. I'm using 57 degrees. What would I call A? My opposite, my adjacent, or my hypotenuse? Opposite. Okay. What would I call 7? Adjacent. Now, what uses opposite and adjacent? Tangent. I'm going to set up an equation that says the tangent of, I actually have an angle this time, 57 degrees, not just a letter, but in actual degrees, is going to equal A over 7. Well, how do you solve that? Let's do some algebra before we go to the calculator. A little bit of algebra. Multiply by 7. I'm just going to write a separate line just so you can first see that fraction one in there. But I'm going to multiply both sides by 7, and I'm going to get A equals 7 times the tangent of 57 degrees. And now you're going to go to your calculator, and you're going to type in 7 tan 57. And unless I tell you otherwise, let's go to the nearest thousandth, which, by the way, means how many places?
3.
Oh, good. And not just cutting off, but rounding. Round appropriately.
Do you want like decimal?
Okay, so first of all, we're going to have to give decimals. The squiggly equal sign means I'm not giving the exact answer because I'm just doing some rounding here. If you write regular equals, no, I won't take off points. Fiona, do you have an answer for this one? What was that? 10.779. And that's what that side is, 10.779. Now, there are any issues so far? There are two ways we can find the remaining side. What could we do to find the remaining side? Pythagorean theorem. I actually don't want to do that only because if I use Pythagorean theorem on a rounded number already, it's going to make my final answer rounded but a little bit further off. I want to make this as close to the actual value as possible. So rather than doing that, let me use some more trig. Lauren.
Can we use?
Okay, so given where we're going to be going with this stuff, I would like you using more trig because for some later things, there's going to be no way around that, and we're going to need this. So I do want you to start that right now. Lauren, what do you want to say? Okay, you know what? Before we do that, there are a couple of ways we could do this. Either using angle 57 degrees or 33 degrees. Lauren, which one do you want to use?
If you're gonna do sine, you're gonna have to do 33.
Okay, so Lauren's saying let's use 33 degrees. When I pick an angle, and honestly either angle would have been okay, I then want to choose the side that I already know to be exact. I'm not going with 10.779, I'm going with 7, and the side I'm looking for. So if we're using 33, 7 would be called the what? Opposite. C is called the? I'm thinking hypotenuse. What is opposite of hypotenuse? As you've been trying to say. Sine. I'm going to set up something saying that the sine of 33 degrees equals 7 over C. So this is what I'm starting from to get my C. That's what I'm starting with to get the A. But this one's going to take a tiny bit more algebra on my end. I need to solve this for C. I think I could maybe put this over 1. And what's the point of that? What can I do? Let's do it. I'm going to say C times the sine of 33 degrees equals 7. So how do I find C? No. Yeah, well, first of all, this is not sine times 33. This is the sine of 33. But can you make me a formula that says C equals? That's what I kind of want right now. Brittany.
You could do 7 divided by sine 33.
That's exactly how we're going to end this. I want to do some algebra first. I want to get basically a formula for the side I'm looking for. And then I can just type that one line into the calculator and be ready to go. So I'm going to say 7 over the sine of 33 degrees. Go type it in. Now it's really just one line of work on your calculator. Leah, do you have an answer for this one?
12.853.
That sounds good. This is about 12.853. And I have solved my triangle. I've got all the sides. Well, I've got all the sides. I've got all the angles. I know I started with like 3 things that were already given. I only had to find 3. But I found everything that I need. I would like you using trig to find all the missing sides, not trig once then Pythagorean theorem, because again, it will mess up the rounding and it will also make later things more complicated. If we're just doing this all the time, it will make things a little bit easier. Next one, letter A. Maybe we'll start letter A, then you'll finish it, and then you'll go do letter B. But what should we do first? Thank you. Does it matter what letter I put where? What's the right angle? Why? Because I told you C was 90 degrees. Could A have been 90 degrees? Look at letter B. Could capital A or B be 90 degrees? Sure, it's just a matter of where we're labeling things. That's kind of, well, we'll get to there in a little bit, right after. Okay, this is A, this is B. A is 32 degrees, little c is 8. I would like you to fill in letters for all the sides, and then find your missing angle. And I'm going to start a list on the side of everything. What is capital B? 180 minus 90 minus 32, 58 degrees. It looks like you're already going. Do you know what to do? How about this? If you think you know what to do, go do letter A. If not, just sit and wait. We'll go through it together, but please don't yet go on to B. Don't go on to B. See what you can do, or wait and we'll talk in a moment. And please don't yet try B. I just want to make sure A is good before you go off to B.
You want us to still work like you did?
I do want to see things at an absolute minimum. I need to see your trig ratio set up, and then basically like what you're going to type into the calculator. So I want to see 7 tan 57, or 7 over sine 30. I need to see that. Okay, so let's start talking about this one. Kiara, letter A, a little a. What angle do you want to use? Do you want to use 32 degrees or 58 degrees? There's no wrong answer. Okay, if you're using 32, oh, actually, I told you we should label these, so we probably should. If we're using 32, what would you call A? Opposite, adjacent, or hypotenuse? Okay, and what would you call the 8? What uses opposite, and this would be something to watch and listen to, Brett, who was waiting for this one. What are we going to call opposite over hypotenuse? What trig function is that? Sine. We're going to set up an equation. The sine of 32 degrees equals A over 8. And then we multiply both sides by 8. We're going to say 8 sine 32 equals A. And what do we have for little a? Anyone? 4.239. Good. Dawson, do you have little b? What angle did you use? Okay. If you're going to use 32, what's little b? Opposite, adjacent, or hypotenuse? Adjacent. And what is that 8 that we have? Hypotenuse. So what are you going to use? Cosine. We're going to say that the cosine of 32 degrees equals little b over 8. Do you guys see where those are coming from? Those of you who are waiting to see the work. Okay, well, multiply both sides by 8. B is going to equal 8 cosine 32. How about like 6.784? Now you're going to try one. What's wrong? Try letter B. Hold on. Can I take the next Yes. No, that's okay. Oh, good. Okay, that's all that really matters. And please make sure when you're doing these, you only use the exact side in your work. Don't use the 4.239 or the 6.784 in your ratios. Use the side that was given, the one that is already a good whole number answer. Letter B. you that B was the right angle, so I'll label it like this. What's that missing angle? 16. And by the way, when you write angles, please make sure you are including the degree sign, because technically without it, it means we're talking about radians, which we will be doing for most of this unit. Make sure you got a degree sign there, or it will mean something different and wrong at this point. So who has some thoughts on this one? Who can share something that they did? Anyone? Alyssa, what do you want to do? Little b, little b, or a little c? Okay. So if you're going to do that, what do you want to use? 16 or 74? Okay. What is 6? Adjacent, opposite, or hypotenuse? Okay. What's b? You know, fine. Look at yours. You're still going to talk about it the same way. Good. And again, it doesn't matter how you drew your picture. You're still going to be using the same opposite, adjacent, whatever ideas. What's your formula for little b before you go to the calculator? So, like, how are we going to solve this equation for little b? Yeah, so give me a formula for b. B equals, like, what can I type it in one step on my calculator now? That's what I want to see. 6 divided by the cosine of 74 degrees, which is 21.768. Michael, how about little c? How did you do little c?
I used the 74.
Okay.
And then I did the, I did the same thing.
That sounds good. Tangent of 74 degrees equals what's on the other side? Good. Which is really just one step to solve. What's basically the formula for c? C equals?
6 times 10
That's it. And what is it?
20.9.
20.92, 4 for 3 places. You did not have to do it the way that Alyssa and Michael did it. You could have found little b using the sine of 16 degrees. You could have found little c using the tangent of 16 degrees. Your formulas will look different, but your final answer should be the same. How are we doing with this?
Good.
Any questions from anyone?
No.
There's one last thing we have to look at that reviews some stuff from geometry. I know you did a little bit more with trig last year, like finding the angles and inverse line. We don't need any of that for what we're about to do, so we're going to skip over that piece. Special right triangles. Hold on one.
stuff after school though.
21.6.
Thank you.
Special right triangles. So, where we're going with this is, so we know how to solve right triangles now using trig, sine, cosine, tangent, and all that stuff. However, if we have triangles in two special forms, we don't need to use any sine, cosine, tangent things to find missing sides. We can just use some special rules from geometry. Here is how this works. Hopefully you remember the ideas of 45, 45, 90 right triangles and 30, 60, 90 right triangles. Hopefully at least the phrase sounds familiar to you. Here's how this works. In a 45, 45, 90 triangle, I'm going to label my sides. What's across from the 45 will get labeled as x, and what's across from the other 45 should get labeled how? Also x, because, well, it's an isosceles triangle. Those are the same. Yeah, I'm sure you saw where this comes from last year. I'm not going to prove things right now, but the hypotenuse is going to be x root 2. Which means, if I know this side is 8, I know this side is 8, and this side is 8 root 2. Okay, 30, 60, 90. Across from the 30 is x. Do any of you remember, either from last year or from maybe the past few weeks in geometry, if you're taking geometry,